So in this video, we'll see how to convert a CFG, that is context-free grammar, to a push-down automata. Okay, so the rules for conversion are, so we already know that there are two parts in a context-free grammar. One is the non-terminals, the other one is the terminal. So let's see how to convert a non-terminal. So non-terminal of the form A tends to alpha. Okay, so you change this to delta of Q. Q is your state, epsilon, then A equal to Q comma alpha. So here this is the template. For everything you write Q comma epsilon. Here also you write Q. But this one is left side of your production. This side is the right side of your production. Okay, this is how you change the non-terminals. Now for the terminals. Okay, how will you change for the terminals? It is just delta of Q comma A is equal to Q comma epsilon. Okay, this is your symbol, right? Input symbol. So here it is the same for all terminals, Q comma epsilon. If we see an example, you will understand. Okay. So this both are input symbols, same input symbol. If A is your input, you write Q comma A comma A. If 0 is your input, you write Q comma 0 comma 0. 1 is your input, Q comma 1 comma 1. Okay. So example 1. So construct a PDA for the grammar S tends to AB, A tends to 0S or 0, B tends to 1S or 1. Okay, so first let's take S tends to AB. All of them are what? All of them are non-terminals, right? So how will you convert that? This is your A, this is your alpha. Okay, so you will write delta of Q comma epsilon comma S. So whatever is on the left side of your transition, okay, equal to Q comma AB. This is whatever on the right side of your transition. Now take the second one. A tends to 0S or 0. First let's do for A tends to 0. So that is delta of Q comma epsilon comma A is equal to Q comma 0 comma, Q comma 0S. Right side of your transition, left side of your transition. Now we will do for A tends to 0. So this is okay, delta of Q comma epsilon comma A equal to Q comma 0. Then third one you have is B tends to 1S. Okay, so here this transition you can write it here as well, like together. Both are A transitions only, no. You can write it together also. Same way you have for B, delta of Q comma epsilon comma whatever on the left side equal to Q comma whatever on the right side. Okay, B has another transition. What is it? B tends to 1. So that is delta of Q comma epsilon comma whatever is on the left side is equal to Q comma whatever on the right side. So this also we can write it here itself. Okay, now the terminal part is over. Now non-terminals are over. So the one left is terminals. How many terminals do you have in this question? 2, 0, comma 1. So how will you write for this? Template is delta of Q comma symbol. So 0 comma 0 equal to Q comma epsilon. Okay, then you write for the symbol 1. 1 comma 1 equal to Q comma 1. So this is how you convert a context-free grammar to a push-down automata. So let's see another example. So S tends to ASA, S tends to BSB, and S tends to C. Okay, now how will you write for non-terminals? S tends to ASA. Okay, so what you will write Q comma delta of Q comma epsilon comma whatever on the left side equal to Q comma whatever on the right side. Okay, then you will have BSB. Okay, here itself you can write Q comma BSB. As it is the same S transition, I including that also here. Okay, now Q comma C. This is your non-terminal transition. How will you write terminal transition? Here you have three terms. This is small c. So you have three terminals A comma B comma C. So for all three you have to write. The template is delta of Q comma the input symbol is equal to Q comma epsilon. Delta of Q comma for B you are writing now Q comma epsilon. Same way for C. Q comma epsilon. So this is how you convert a context-free grammar to a push-down automaton.